In this video, I want to go over Venn diagrams and how they can be used to help prove that two sets are equal. Let's get started. So to begin, we remember that we can use Venn diagrams to describe how different sets are related to another. When filling in the regions of a Venn diagram for three sets, remember that we always begin in the overlapping region. And what was that called again? That's right, the intersection of our three sets in this case. So again, if I had a picture here like I do in my example, if I'm using three sets, I would use three different circles, and I'd write them in such a way or draw them in such a way that there is an overlap of all three circles somewhere, as well as an overlap with just two at a time in each of these regions. And then you can see there's room here for just what's unique to that set, unique to this set, unique to this set. That has to do with that set difference idea we talked about last time. And then floating out here, we use our capital italicized letter U for the universal set. Okay, so let's begin here. We fill in the overlapping regions, starting with where they have something in common, so we'd always start there. And then we'd move into our overlapping two sets at a time only, and then finally into the region unique to each set. And then the last thing we would do is out here. Okay, so if you're trying to figure out the order of things, you work your way from the inside out. Okay, so let me erase some of that pretty notation that I just drew on your Venn diagram. All right, so let's take a look at this example and see if we could in fact use a Venn diagram to describe this Olympic situation from 2008. So it says here, consider the following table which shows countries that won at least 25 medals in the 2008 Summer Olympics. Let the countries in the table represent the universal set. Okay, so the source of this was the United States Olympic Committee. All right, so we're taking a look here. It said that in 2008, the United States, for example, won 36 gold medals, whereas China won 51, Russia won 23, and then it goes on from there to talk about other countries like Great Britain all the way down to Japan. Okay, so again, the qualification in order to be in this chart was you had to be a country that won at least 25 medals total. All right, but then they break them down into some subcategories, right? Usually we track how many gold medals, right? How many silver medals, how many bronze medals, not just the totals. So here, let's take a look at how they've chosen to identify our three sets here for our Venn diagram. So let's take first a look at set A. So it's kind of hard to read, I'll read it to you. Set A is the set of countries that won at least 30 gold medals. So at least means, you know, that number or more, right? So it's the minimum and it includes it. So at least 30 gold medals. So I'm going to go ahead and choose the circle on the top left here as set A. So to be in this set, I have to have at least 30 gold medals. So what I'll do off to the side here is I'll start writing a set in list notation. So set A would consist of which member countries, which elements here? Well, let's take a quick look. In order to be in the set, we need at least 30 gold medals. Does the United States qualify? In that year, they did. So this would be US or USA. China qualifies. They had 51, so I'm going to do CH for China. Okay. Russia, did they have at least 30 that year? No. How about Great Britain? 19. I don't see 30 anywhere else. They're all below 30. So in fact, I had more room than I needed. This just has two elements in set A. So that's a very unique set, just United States and China in set A. So for my circle here, the United States and China are the only two elements in that circle. Now, where I want to put them will be determined whether or not they share any elements in common, right, with B or C. So let's take a look at what it takes to be a member of set B here. I'll do purple for B. So to be in set B, it said, you're going to be in B if you're a country that won at least 15 silver medals. At least 15 silver medals. So let's take a look at who's in set B. At least 15 silver medals. So looking at the silver medal column, the US would qualify for that as well. China has 21, so they qualify. I'll do CH for China. Russia had 21, that's at least 15. So Russia, I'll put RU for them. Great Britain, or the UK, we'll say Great Britain, not to be confusing you. They only had 13, so that would not qualify in this particular Olympic Games for silver medals here. But Australia does have 15, so I'll put AU for Australia. And are there anyone else that qualifies? Let's see. Down here, France. Yep, I'll put FR for France. I don't see any others that qualified that year. Do you? If I made a mistake, you can always message me later. All right. So the US, China, Russia, Australia, and France would be in set B, the set of countries who earned at least 15 silver medals. Now let's look at set C. Maybe it's a little more inclusive. Let's take a look. So it's set C. To be a member of set C, it says you had to be a country that won at least 10 bronze medals, at least 10 bronze medals. So looking at my bronze column here, the United States qualifies because they have 36. So again, it looks like the US is in all 3 of these sets. China has 28, which is at least 10. So China qualifies again in all 3 of these sets. That might tell you something about our picture here. Russia has 28 bronze, so they qualify. RU. Who else qualifies? Great Britain has 15, which is more than 10, so this 10 or more. So this is definitely allowed, so I'll put GB to be easy on the eyes here. Great Britain. Australia has 17, so I'm going to put AU in set C here. What about Germany? Germany has 15, so they're good. I'll put GM for Germany. Just kind of making that up as I go along. Let's see. France has 17, so that also is included. I'll put FR. South Korea. Oh, it looks like they only have 8. My husband will be sad. They only have 8. Okay, so that will be a exclusion from our set. Italy. Now here, watch your wording here. It says at least 10. Okay, at least 10. Would that include Italy? It would, right? Because at least means that number or higher. So Italy would be included. I'll put IT for Italy. Ukraine, 15. That would be included. I'm going to run out of room here. I'm going to put UN. I know it's not really making sense, but I don't want to confuse you with UK and think it's Great Britain. So I'm going to put UN for Ukraine. And then Japan would also be included because they had 10. So this would be a wraparound here. I'm going to put JP. And then our set would close. Sorry about the ugliness of that set. There should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements. I'll read them to you again. United States, China, Russia, Great Britain, Australia, Germany, France, Italy, Ukraine, and Japan. Okay, so that is a massive set, and we'll have a hard time squeezing everything in here. Now notice that the universal set would consist of all of the countries in this list, because to qualify in the list, you just had to have at least 25 medals. So there will be some elements that are floating around outside of these 3 circles. So let's begin with our Venn diagram here. Remember A, I said was going to be our circle here on the left. Maybe I'll let B, our purple circle here, be this one here. And C, which will have the most elements inside, it looks like, be down here. Okay. So to begin with A, B, or C would not be the way to go. Where should I begin? We talked about this earlier. Always begin in the overlapping region. So what do they all share in common? What is the intersection? I'll write it out separately for us here. Pick a new color, perhaps yellow. What is the intersection of A and B and C? That's what that says, right? What do A, B, and C have in common? Do they have anything in common? All 3. Take a look. Yeah, which countries are in all 3 of them? The United States and China, right? The United States and China appear to be in all 3 of them. So US and China are the only 2 countries in the intersection of all 3 sets. So we'd put US. That's kind of hard to read. Let me go back to my colors here. I will pick brown. US and China. And again, you can make your circles bigger if you need more room to write. Okay, I just wanted to get the basic idea. So that's where we would begin. The next thing we might want to do is say what elements are in A and B. Okay, well, A and B, we already talked about US and China, so those are already there. Do they share anything else in common? Well, no, the rest of them are just unique to B, but not in A. So these elements here, Russia, Australia, and France, notice they're not shared in A, so they would not be able to go in this region here, this overlapping part of A and B. So the only thing that A and B have in common is what is also in the third set C. So this is going to actually be an empty part of our Venn diagram, okay? Then I would go to the next overlap. Okay, so we did A and B. What do B and C have in common, for example? Do B and C share any elements in common? So let's take a look. Maybe I can find another color that I haven't used yet. Probably not, but I'll try. So what do B and C share in common? Well, we already know they share the US and China, right? But do they share anything else in common? Well, they do. They share Russia. What else? Australia. Anything else? And France. In fact, all of the elements that are left in B are also found in C, aren't they? So we would notice that those elements, Russia, Australia, and France, would go in this remaining overlap between B and C. So I'm going to put R, U, A, U for Australia, and FR for France. So those would be the elements that are in B and C, but not in A, right? Okay. Finally, the last overlapping region, so we've already talked about A and B. They didn't share anything besides what was already in C, so just the United States and China. We've talked about B and C. They had some extras that they shared in common besides the United States and China. But what about A and C? Do they share anything else? Well, you can see that A has already been used up. United States and China we've already talked about here and here as well. So there's nothing unique to just A and C, right? They also share it with B. So those two have been discussed. So now that we've done the interior most and then the overlapping two at a time, the next thing we would do, we work our way from the inside out, is we say, okay, what is unique to A alone? Is there anything left in A that we have not already discussed? And that's why I think it's really helpful to kind of mark what you've already used, right? So I've already talked about United States, I've already talked about China. So is there anything left in here by itself that's just unique to A? Not this time, so this part would be left blank. What about items that are unique to B? Are there anything in this Venn diagram unique to B? Well, no, we've already used all of those elements between the three of them and then between B and C. So this region, this time is empty as well. But there is one region that has some unique elements, and that would be in C, right? So take a look at C. We had GB, Great Britain. They were only found in set C. They weren't found in sets A or B. We also noticed, besides Great Britain, we also had Germany. I said GM for Germany, remember? We already talked about France. We also have Italy. I'll do IT for Italy, okay? We also had Ukraine. I think I did UN for Ukraine. And then I had Japan, JP, okay? So we had 5 elements which were unique to set C, okay? I know it gets a little weird with these big country names. Typically, these are numbers or something a little bit easier for you to use than these big words, okay? But there is one other thing you need to do. Before you finish your Venn diagram, before you say, I've completely described the situation with my picture, okay? You have to account for any element in the universal set that may be floating around, not nicely fitting into one of those other three, in this case, circles. So are there any items which are in the universal set, but are not found in any of these 3 sets, A, B, or C? Well, it does look like there are. We've already talked about the United States. We've talked about China. We've talked about Russia, Great Britain, Australia, Germany, France. But there was one country I think we mentioned that did not appear in any of the other sets, and that was South Korea, because it didn't qualify for any of those metrics, right? It didn't have enough bronze, silver, or gold medals. So we would say that South Korea would actually be in the universal set because it qualified by making at least 25 medals in the 2008 Olympic Games, but it doesn't qualify into one of these nicely formed categories that we've already predetermined. Well, that was a complicated Venn diagram because of all the countries, but in general, I hope that that makes a little bit of sense as to how to form your own Venn diagram. We begin with what do they share in common, what do 2 sets share in common at a time, and then finally, what are unique to those individual sets and what is floating in the universal set. All right, with that in mind, let's see if you can apply it in our next example. Example 1. It says, can you construct a Venn diagram for the sets below in the universal set of people who like different genres of music? So the universal set is consisting of who? People who like different genres of music. That's almost everybody on Earth, unless you don't like music. All right, so the universal set consists of all people who like different genres of music. Now, what they've done is they've categorized people based on their particular genre preferences. So let's take a look at who is in set A, for example. So to be in set A, they said, you're someone who likes pop music, you're someone who also likes country music, and you're someone who likes classical music. If you like one of these 3, or all of these 3, yes, I should say, then you would be a person in set A. So a person in set A likes all 3 of those genres. Now, before I go ahead and start writing set A, pop, country, classical, remember, I don't start my Venn diagram in a particular set. Where do I start it? That's right, in the overlapping region, if they share anything in common. So make sure that as you pause the video and try it yourself, that's where you begin. All right. As we look at set B, that's going to consist of people who like these 3 genres, pop, emo music, and country music. And then finally for set C, so I'll put B maybe as this circle. I used another color because I already used that one, didn't I? That was red. B. And then for C, I'll use black. To be in C, you have to be someone who likes a lot of different genres. Classical music, country music, emo music, techno music, and jazz music. Okay, so these are very interesting sets of people, eclectic people maybe. All right, so let's take a look at how you drew your Venn diagram. So first of all, hopefully you started with labeling your three sets, A, B, and C, and making sure that your universal set has the name U, the italicized capital letter U. And then where did you begin? Hopefully you'll tell me that you began in the overlapping region. Very good. So is there anything in common between these three sets? Do they share any genres of music in common? If you said country, I see country in A, that's right. I see it in B. Oh, I do see it in C. So if you said country, I would agree with you. If you said pop, I would almost agree with you because it is in A and B, but it's not in C. And if you said classical, I'd also almost agree with you because it's in A and it's in C, but it's not in B. Okay, and emo for the same reasons. It's in B and C, but not in A. Okay, so the only one that's in all three is country. I'm going to use C-O for that, for country. All right, so country would be in all three. So someone who likes country would be in all three sets. All right, so where do we go next? Do you remember? That's right, we go to what they had in common in just two of the sets. So let's say A and B. Are there any elements that A and B shared besides country? So we already talked about country. Well, yeah, they share the pop music, don't they? A and B share pop. They don't share classical or emo, though. So I would put pop. I could probably write it all out. Pop right there. Okay. So they share pop in common. Okay, so what about between sets A and C and between sets B and C? Let's take a look. For A and C, we already talked about country that they shared. They don't have pop in common, but they do appear to have classical in common, don't they? They have classical in common. So I'm going to put classical, maybe CL for classical. This is between A and C, right? Make sure I'm looking in the right region. A and C, yep. So there's classical. So that we already know they shared country in common because that's in common for all three. But they also share, A and C share classical music in common just between those two sets. And finally, let's look between B and C. B and C, well, they shared country already, and they don't share pop, but they do share emo, don't they? So emo would go here. I could probably spell that out, emo. Okay. All right, now where did you go next? After you've created your Venn diagram in the center and now you've done your two at a time overlaps, where did you go next? If you said unique to A, B, or C, that's exactly what I would have done. Good job. What does A have uniquely in common with itself? What's only in A? Well, nothing, right? Notice that we've already talked about pop, country, and classical. Pop, country, and classical. So this region here is empty this time. What about unique to B? Is there anything unique to B? Well, we've already talked about pop, emo, and country, so no, that would also be blank this time. Kind of boring. Okay, what about unique to C? Well, there are two more that are unique to C, two more genres. That would be techno. I could probably fit it all since there's not a lot to write here. And jazz. Those two would be unique to C. Okay. Now, there are other elements that are probably found in this universal set, right? Everyone else who likes different types of music, punk, rock, indie, there are all kinds of different types of music that would be floating around in this universal set. So keep that in mind. If this is truly every person who likes a different genre of music, this would include a whole lot of people. Okay. But I wanted you to get the idea with a more basic problem like this one of how to get started. In the intersection, then the two at a time overlapping regions, then what is unique to each of the three sets, if there is anything, followed by what's floating around in the universal set, if you can clearly identify that. All right, let's head over to our next slide and see how we can build on this knowledge. Okay, the last piece of information to build on when we're talking about Venn diagrams is how we can use Venn diagrams to prove the two sets are equal. And the way we're going to do this is by drawing ourselves a pretty Venn diagram like we have here. If we're talking about two sets, so we just need two overlapping circles. We're assuming that they're not disjoint, so they can overlap. And we say that we can use Venn diagrams to prove that two sets are equal by showing that their elements occupy the exact same, that's our first blank here, our exact same region of the diagram. Okay, so what do we mean by this? All right, well, we can sometimes describe things in different ways, but if in the end their elements are exactly the same, then the two sets are equal. And we kind of talked about this in a previous slide. There's an important rule that you're going to want to write down on your note card. I boxed it on your slide here, and that's called De Morgan's Law, or De Morgan's Laws. We're going to show you one aspect of them on this slide. This aspect of De Morgan's Law says if you take the, remember this symbol here, the apostrophe looking symbol, it means the complement, right? Complement. If you take the complement of the union of A and B, so in parentheses it's A union B, and then outside it's the complement. So it says the complement of A union B equals A complement intersect B complement. Interesting. So this is one piece of De Morgan's Law, and here's the other piece. It says the complement of the intersection of A and B equals the union of the complements of A and B. The union of A complement and B complement, right? Okay, now this might seem a little wonky, and that's okay because it's very theoretical right now. But I'm going to show you with the Venn diagram how this works in just a moment, okay? Keep in mind, if you ever remember from algebra class, we had something called distributing. When you had parentheses and a negative sign, we distribute. You can kind of think of that as what's happening here. The complement is getting distributed to the A and the B that are inside parentheses. But when that happens, notice what changes with your intersection and your unions. They flip, don't they? So when you end up distributing, if you will, with De Morgan's Law, that's what it does. Some people like to remember this with distribute and flip. Distribute the complements and flip the connective. Distribute the complements and flip the connective. That's what De Morgan's Law is really doing. It's distributing the complements that were in the parenthesis of what's in the parenthesis and flipping the connective inside the parenthesis. All right, so how can I prove this, and how does it make any sense? Well, what I would recommend if you're trying to prove that two sets are equal is first begin by labeling different regions of the Venn diagram. So if I use just our normal Roman numerals, 1, 2, 3, etc., I can start off by saying, I'm going to call this region 1. Some textbooks, in fact, your homework might even do this online, will use Roman numerals, so just be aware of that, the Roman numerals 1 through 4, 6, however many you're using. In this case, I'm just going to use the regular numbers here. 1, 2, 3. Is there any other region of the graph I need to worry about? That's right, out here floating around in our universal set. That would be region 4. So the elements which are in the universal set but not in one of the two sets A and B. And then I'm going to label set A on the left and set B on the right. Okay, so how would I prove, using this Venn diagram, the following De Morgan Law, which says that the complement of A union B equals the intersection of A and B? Complement. So in order to do that, what I would do is I'd start off by looking on the left side. So let me make some space here. Oops, I meant to get an eraser. Let me grab the right tool for you. Okay, erase. Oh, I think I erased too much. One moment. And go back. There we go. I'll just rewrite real quickly what I had. Just apologize for any inconvenience. That was 1, that was 2, that was 3, that was 4, and there was our universal set. Oh, I see what I did. I went one slide ahead. Bear with me. There we go. Now I'm on the right page for you. There's 1, there's 2, there's 3, there's 4. You got a preview of what's coming in a second. All right, so how would I prove that these two things are equal? This is De Morgan's Law. Well, we would start off on the left side. On the left side here, left, and then we'll do the right side. Right. All right, so on the left side, I want to begin by discussing who is in each of these sets. So on the left side of my equal sign here, I have A union B, and then take the complement. So first, where do we start? We started with A union B. So who is in A and in B? Okay, so if you're in A or B, then you're in the union, right? So which elements would be described there? And I'll go ahead and pretend that they're elements for a moment, even though they're really regions. So this would be the set 1, 2, 3. That would be what I'm talking about here, A union B. Those would be the regions we're talking about. Thinking of them as elements for a moment, it might make it easier. So that's 1, 2, and 3 in the set. But then I want to take the complement of that, right? So the complement of that set would be everything that's missing from the universal set that's not already in this set. So in the universal set, I'd also need to include this 4, wouldn't I? So that would be our complement here. All right. So what we'd be talking about on the left side is just the region out here. So let me get our color coordination right here for you. So we're talking about just this region out here that includes elements which are not in either one of the two sets, right? That's what we're talking about when we say the set in that region, okay? But let's see if that's the same thing on the right side of this situation. So let's go to our right side here. Here we're supposed to find A complement intersected with B complement. So where do we begin? That's right, with A complement. So A complement would be everything that is missing from A to complete the universal set. So I don't need 1, I don't need 2. What am I missing to complete the universal set? I'm missing 3 and 4. That's right. That's A complement. And then we're supposed to intersect that with B complement, which means everything that B is missing that would be necessary to complete the set. So let's erase this for a second. There you go. Get my color back. Let's fix this number 1. And let's get going with our B complement now. So who would B complement be? Feel free to pause the video and see if you can get that part right. Yeah, B complement would be everything that B does not already have, that it's missing to complete the universal set. So we already have a 1, we already have a 3, so who's missing? That's right, the 2 and the 4. Okay, so now taking a look at that, how do I find the intersection of two sets again? Good job, you find what they have in common. And what do they have in common? Just 4. Now, again, going back to our definition above, we said that two sets are equal if we can show that their elements occupy exactly the same regions. Did we occupy exactly the same regions? Region 4. Yep, so this outside region is what we're talking about in this case. Elements which are in the universal set but not nicely found in A or B. Okay, now you could actually take a moment, pause the video, and try to prove the other De Morgan's law here. So we just proved the first one here. Could you go ahead and prove this one using the same idea that we did in this video? I encourage you to try it and reach out to me if you have any questions. Once you do that, you're ready for your last example. Here we go. Example 2. Use Venn diagrams to prove that this is true, that the complement of A intersect B is equal to A complement union B complement. In fact, I think this is what I asked you to prove already, so you might already be done. But let's take a look how you did. So how did you do this? Well, hopefully you started off by writing A and B to describe each of your two sets, and maybe naming your universal set U, okay? And then what was one way that you could show each region? Using numbers, good job. So maybe you use Roman numerals, maybe you use our regular number system, 1, 2, 3, 4. Again, you don't have to number them in any particular order, it's just that you want to identify each region clearly. And then what did we do? We said start on the left side, and then look at the right side and see if you end up in the same place. If you're not in exactly the same region, then they're not equal. So if you had like 2 and 3 and then 1 and 4, or 2 and 3 and just 3, those would not be equal. Okay. So let's take a look here. Starting inside the parentheses, we would have A intersect B. So what did that mean again? What do A and B have in common? Intersection in common, right? What do A and B have in common? Well, that's just this region, right? Region 1, or if you think of it as an element of a set for now, that would just be set with the number 1 inside, okay? And then we're supposed to take its complement. So what would the complement be of that set? It would be the set of all elements which would help complete it, right, with the universal set. So it's missing the 2, it's missing the 3, and it's missing the 4. So that would be 2, 3, and 4. So the regions, if you will, that this describes is everything unique to A, everything unique to B, and everything outside of the circles. That would be the region that we're talking about here on the left side. Let's see if that's exactly the same region we get on the right side, shall we? Notice the only thing that was missing there was the overlapping region, right? Okay. So on the right side, we're asked to find the union of A complement and B complement. So let's start with A complement. To find A complement, what did we do? Everything that is missing from A that we need to complete the universal set. So what is A missing? So A has just a 2 and a 1. So what would A complement be? So it already has 2, it already has 1. What would A complement need? It would need 3 and 4. Very good. And then we're supposed to unite that with B complement. So what is B complement? Everything that B needs to complete the universal set. So B already has a 1 and a 3. So what is it missing from the universal set? 2 and a 4. And finally, how do you take a union? not an intersection, but a union. You unite, right? Put them all in the pot together. So 2, 3, and 4 would be our answer here. If this had said intersection, that would be very different, right? That would just be what they have in common. Are those the exact same regions that we had on the left side, rather? They are. So again, we're talking about this region, and outside. So those are the 3 regions that are described on both the left and right side of the equation, which means that we have proven, in fact, that De Morgan's law is true. You do, in fact, distribute and flip the connective. So in your homework, you're going to get more practice proving that 2 sets are equal by making yourself a Venn diagram, labeling each region with a number, and then showing that you do, in fact, end up in exactly the same places of the Venn diagram. I hope this video is helpful. If you have any questions, don't hesitate to reach out to me. Other than that, happy practicing, because math is not a spectator sport. I'll see you next time.